Welcome to the second part of transformations of functions. In the first part, we talked about vertical and horizontal shifts. We said that when we have this is our graph. So we have a curve here. If we want to shift it upward, we have to do some operations. This is the graph of x squared. We have to do some operations on x squared to move our function, our graph from here to upward. If we want to move it downward, we do some operations. So we illustrated that with examples. You will find a card here. If you didn't watch it, you can watch it. So we continue now with the second part. It is about vertical and horizontal stretching, shrinking, and reflecting. Suppose that C is greater than 1 to obtain the graph of, so we have 1 property, 2 properties, 3 properties, 4, 5, 6 properties. We'll go directly through examples. Let's start with the first example is vertical stretching and shrinking. So this is the original curve, okay? So y is equal to cosine of x. If I want to stretch my curve vertically, I have to do something here with cosine of x to make it moving between, for example, 2 and -2. So it will become like that. You see, it is stretched upward and downward on y-axis. If I want to shrink it, I will do it as follow. It is coming from here, so I will make it, for example, between this means it is shrinking but vertically, okay? It is between half and -half, okay? So this is the idea of vertically stretching and shrinking, okay? Let's see the first property, y is equal to C. C can be any number except we don't take 1 because here it is already 1, you see? So we take 2 or 3 or 4, okay? So C multiplied by f of x. This stretches the graph of y is equal to f of x or graph function, so vertically by a factor of C. So we said this is the original one, okay? It is moving between 1 and -1, okay? Because here, if you don't have any number, it is 1, so that's why it is between 1 and -1. Now, what if we multiply it by 2? So this means 2 is C in this case, okay? So 2 multiplied by cosine of x, this stretches, meaning we make it larger, but vertically, okay? So 2. So by factor 2, this means by factor of C, this means it is 2 here, it is 2 and -2. So our curve moves between 2, -2, 2, -2, like waves, and it continues to infinity, okay? Now, what if I want to shrink it? Shrink it, as we said, we make it smaller, but vertically, meaning we want our function to move between, for example, half and -half, half and -half. So what we do is we multiply 1 over C by f of x. So this shrink the graph of y is equal to f of x, our function, vertically on y-axis. This is y-axis, vertically by a factor of C. Okay, so let's do it. You see, we multiply 1 over 2 by cosine of x. So 1 over 2 multiplied by cosine of x, you see, this green one, it moves between half, half. You see, this is the half of 1. So this is 1 over 2. Okay, this here it will be -1 over 2. Okay, so this is the idea of shrinking and stretching. So one more time, stretching, we stretch our curve vertically on y-axis. by multiplying a number c. It can be c can be equal to 2, c can be equal to 3, 4, 5, okay? So by a factor c by the function, and this stretches the curve. If I want to shrink it vertically, so shrink the graph vertically, so c is 1 over 2, that's why our curve moves between half, 1 over 2, and minus 1 over 2, and it continues like that, okay? Let's see second example. Now, for the second example, it is about horizontal stretching and shrinking, okay? So, horizontal stretching and shrinking, meaning this means we keep our function, our curve, this is our curve, okay, this is cosine of x. We will keep it between 1 and minus 1, but we will shrink it on x-axis, or we will stretch it on x-axis, meaning if I want to shrink this curve, so I will make it between horizontally, I will do some operations on x to make it like that. You see the movement, it is moving a lot, many waves, but it is always between 1 and minus 1. You see, this is shrinking, so horizontally. Now, if I want to stretch it horizontally, it will be like that. You see, it is stretched horizontally, but it is always between 1 and minus 1. So the idea is here. Let's see the example. First property. So first property is to shrink our curve. We multiply c by x. Okay. So when we multiply c by x, this shrink the graph of y is equal to f of x horizontally by a factor of c. Let's do it. Here, horizontally, to shrink it, we multiply c by x, meaning c is inside, so inside the operation, inside the function, okay? So now cosine of 2x is shrinking our curve. You see, it is moving a lot, between 1 minus 1, 1 minus 1, 1 minus 1, but it is moving a lot, okay? This is the idea of y is equal to f of x, c multiplied by x. This shrink the graph of y is equal to f of x horizontally by a factor of c, okay? C is important, you see. So now let's take, and as we said, we don't take c. C should not be equal to 0, and c should not be equal to 1 also, because 1 does not change anything. 1 is here, okay? That's why c is better to be greater than 1, okay? Now, let's see second property with horizontal stretching and shrinking. Second property is y is equal to f of x over c. So this stretches the graph of y is equal to f of x, our function, horizontally, okay, by a factor of c. Let's do it. So you see, in this case, when we take y is equal to cosine of x over 2, so we divide a number by 2. So this means we are stretching our curve horizontally, but you see, it is always between 1 and minus 1, but you see it does not move a lot, like 2 multiplied by x. So now if we take x over 2, so this means we are moving slowly, meaning we don't have a lot of waves, okay? So this is the idea of x over c, f of x over c. So this is stretching the graph horizontally by a factor of c, okay? Let's see third example with reflecting of a graph with x-axis. So what we need to do is, this is our graph, the function, y is equal to 2 to the power x. This is exponential function, okay? It is above x-axis, right? So I want to take it down and I want to make it like that, okay? So for this case, I need to do some operations. So what we are going to do is, with this property, y is equal to minus f of x, this reflects the graph of y is equal to f of x about the x-axis, okay? So meaning, if I take minus y is equal to minus 2 to the power x, you see we had positive, here is negative, so this reflects my graph with x-axis, you see. Or for example, we had also, for example, this is x squared, right? So if I want to reflect it from on x-axis, I will do it as follow. I will just take this. This is minus x squared, okay? So this is the idea. Let's see fourth example with reflecting of a graph with y-axis. So in last case it was with x-axis, okay? Now with y-axis, meaning y is equal to f of minus x. So minus will get into the operation, okay? Meaning, first reflecting with y-axis, this means I want to move this to the other side. So I will reflect it, it will become like that, okay? So this means the reflecting on y-axis. So let's do it. We take y is equal to 2 to the power minus x, you see? So I do the operation on x. So in this case, when I do the operation with x, this reflects my graph on y with y-axis, about y-axis, okay? This is y-axis. And that's the idea in general. Thank you for watching, and hope to see you in the next video.